again, hopefully, if you have this problem, how are you determined to use a normal CDF or the inverse norm? And if we use a normal CDF, do we use a population standard deviation or a sample standard deviation, right? So again, that's the objective for today. This is our goal, is hopefully if you see this problem on over this weekend on your test, you would able to identify the difference among the part in the question, right? So let's take a look at example 1. They say, suppose that in a bowling league, the score among the all bowler are normally distributed, distributed with the mean of 182 point and the standard deviation of 14 point. Find the following. So again, find the proportion of the population, find the probability of a random sample, person selected. And again, if you look at this thing here, hopefully this is the item that you want to see, which is, again, first of all, if they ask you to find a proportion of a population, then we will use the information they give us, which is we will use the population mean and we will use the population standard deviation. Okay. Or the other thing that I want to point out is if they don't mention anything about a sample, if they don't mention anything about a sample, then we are dealing with a population item. We are dealing with a population item, which is, if you look at A, B, C, and D, you can see that A, they ask you to find a proportion of a population, which is now we will use these two items, which is the mu and the sigma, which is your population information. And if they don't mention about anything about sample, which is, again, this thing here is basically based on this population, can you find the probability, which is for B, we're still using the population data. Only when they mention about a sample, what is the probability that a sample mean? Only when they mention about sample, that is when we have to do some adjustment. We still use the normal CDF, but we have to find some adjustment to do. Okay, so let's take a look at A. Let's take a look at A. If you were to do this over weekend, they ask you find the proportion of the population who score more than 195 point in this bowling, right? So looking at this thing here, we know that this is my mean, this is my standard deviation. Now all you need to do is sketch your item, which is, this is my 195 point, right? And again, looking at this thing here, more than 195 mean I'm looking for the area under the curve to the right of 195, because anything to the right of 195 is more than 195, right? Which is, again, this sketch is not precise, right? Because the mean is 182, so 195 should be somewhere over here. But again, we don't really have to be precise. We just have to know what area am I looking for, so that I know what kind of endpoint I should looking for, right? So looking at this thing here, we're looking for the area, we're looking for a proportion. We know that we have to use normal CDF. Reminder that your normal CDF, in order to use the normal CDF, you need the lower limit, the upper limit, the mean, and the standard deviation. The mean we already have, the standard we already have, which is now what is your lower limit. The smallest number we can see on the left is 195, and the bigger number we can see or that we need is some humongous number on the right, which is reminder that this is what we have, which is the normal CDF 195 comma 10 million comma the mean 182 and the standard deviation 14, which is, again, if we deal with the population, we have 14 as in a population standard deviation. And you type it in your calculator, your answer will be 0.1766. And similarly with B, they ask you find the probability. And again, this is the other thing that they ask you is find the probability, which is the same as the area under the curve, that the person score less than 150. So how do we score less than 150? Well, less than 150, anything to the left of 150 is less than 150. So looking at this thing here, we know that we're looking for this item, which is, again, we still use the normal CDF. It's just that now my endpoint is some negative humongous number, which is negative 1 million or 10 million. And the upper endpoint or the upper limit will be 150, which is again, looking at this thing here, we have normal CDF, negative a million or 10 million, 150 comma, the same mean, which is 182, the same standard deviation, which is 14, and this will give you 0.011. And as you can see, my percentage is not accurate, right? 0.01 is roughly 1%, it's like very small. But if I highlight that, it's too small, you don't see it. So that's why I sketch it this way so that you can see that we're looking for the area to the left of that point. So again, you know, the sketching part is just for you to have an idea of how the endpoint would look like, okay? So first of all, question with A and B, how to determine if we're using the population standard deviation here. And if you look at C, now as you can see, they say suppose that a sample. So anything as you will see from here on out, which is in chapter 7 and chapter 8, whenever we deal with sample, we have to do some adjustment, right? So in this case, they say suppose that a sample of 100 roller is selected. What is the probability a sample mean score is greater than 195? So if you look at this thing here, greater than is the same as more than, right? But again, I give you the same kind of same question. The only thing different is hopefully you guys see that we are deal with a sample. And if we deal with a sample, we have to do a small adjustment. We cannot use the population standard deviation to calculate the sample, right? We have to convert this, which is the central limit theorem tell us that we can convert this to a sample population. I mean, sorry, a sample standard deviation, not a sample population. Sample standard deviation, and to do that, we take a standard deviation divided by a square root of n. So this is your adjusted standard deviation, or this is the sample standard deviation, which is again, my n is the sample, which is my sample size 100, which is I have 14 divided by square root of 100, which is in this case, I have again, 1.4. Square root of 100 is 10, so 14 divided by 10 is 1.4, right? So looking at this thing here, to go back to this item, like I mentioned, greater than is the same as more than, right? Anything to the right of 195 is greater than 195. So looking at this item here, if you use this, as you can see, the only thing different between A versus C is we are not using 14 rather than we use 1.4 because we have to adjust the standard deviation to become a sample standard deviation. And again, once you have this thing here, ladies and gentlemen, your answer is 8.1606 times 10 to the negative 21. What does the negative 21 mean? The negative 21 is basically tell you take this decimal and move 21 places to the left. Meaning between a decimal to the number 8, there are 20 different zeros, right? Meaning look at this thing here is very humongously small. Very, very small. Cannot be humongously small, right? Again, this thing is very, very small. It's very small. This thing is actually smaller than the probability of you winning the Powerball. But again, it's very rare, right? But again, as long as there's a probability, you will be able to, you know, they have a chance that they can make it. Okay. So looking at this thing here, question, first of all, question on how to determine if we need to adjust the standard deviation so that we can use the new standard deviation versus why we're just using the information they're giving us. And lastly, if you don't have question with A, B, and C, hopefully in part D, you can see that they actually find the probability that a sample mean, which is sample mean, we have to use the adjusted standard deviation or the sample standard deviation, which is again, we're using the 1.4. Sample mean is between 175 and 185. So looking at this thing here, we sketch our item, which is again, if we sketch our item, this is the 2 endpoint we're looking for, which is in between. There's no sugar coating, right? In between, we look at area in between this thing here, which is again, my lower endpoint will be 175. My upper endpoint will be 185. My mean will be 182, and the standard deviation is 1.4. which is, as you can see, based on this thing here, the answer will be 0.9839, which is, again, in between. Those are the two endpoints that you will be using. If you're looking for the area to the right, then you start with a small endpoint and you end up with a humongous number, which is, for me, we use 10 million. If you're looking for area to the left, you have to start with a small negative 10 million, and then your upper endpoint is the point that we're looking for. Okay, so distinguish the left side and the right side and in between. So looking at this thing here, question with A or B or C or D here. All right, let me erase. So again, if you don't have question with this thing here, let's continue with example 1, and let's say they change it up, which is, some of you guys asked me yesterday, how do you know if we're using a normal CDF versus inverse norm, right? So the previous 4 problem, we deal with normal CDF. It's just that if we deal with population, we using the regular standard deviation, population standard deviation. If we deal with a sample, we have to use a sample standard deviation, which is take the population standard deviation divided by square root of n. So looking at this thing here, for D, they ask you, a trophy is given, again, same information, a trophy is given to each player who score at or above the 97th percentile. What is the minimum score needed for a bowler to receive this trophy? So hopefully you guys see that looking at this item here, they give us the percentile, or in another word, they give us the percentage to the left, right? So looking at this item, if they give us the percentile or if they give us a percentage, then we know that we have to use the inverse norm, because again, they not ask me. If you remember the previous example, they asked you to find the probability, find the proportional proportion of the population, right? So if they ask you find probability, proportion, or the area, we use your normal CDF. If they ask you find the score, or they give you the percentile, the quartile, or the percentage, then you have to do the inverse norm, right? So looking at this thing here, if you remember, the percentile is basically tell you that the 97th percentile, which is the 97% to the left of that value, meaning if you score whatever you score, you will be on the 97th percentile, meaning there are 96 people. Based on the next one, there are 96 people below your score, right? So looking at this item here, how do we do this? So if we remember that we have the percentage or the percentile in this case, then we have to use the inverse norm. Reminder, your inverse norm, they only calculate, for my calculator, for the one that I show you guys, that they only calculate the area to the left, meaning you have to give them the area to the left, the mean, the standard deviation, and then they calculate the value for you. If you have the advanced calculator, then you can tell them, oh, the area to the left, area to the left, area to the right, or something in that nature. Okay. So again, looking at this thing here, do you agree that the area to the left is the 0.97, which is the 97%? And the mean is 182, and the standard deviation is 14, which is, in this case, you have to score at least 208.33. But because of the score, because of the polling pin is a discrete variable, it's a discrete data, that's why they say, oh, round up to 209, because you cannot score a third of a pin, right? The pin either fall or doesn't fall. So again, you have to score the whole pin, which is, they just say round up to the whole pin, which is 209 pin. So if you score 209 pin or more, the maximum score for a game is 300. So if you score 209 or more, you will get this trophy based on this information here. Based on this group of data, this is what you have, okay? And again, if you look at D versus E, again, they give you the percentile, but hopefully you guys can zoom in and say, oh, they give us, or they tell us that we need to find the 49th percentile of the sample mean. Because there's a sample mean, we cannot use 14 as our standard deviation. we have to use the sample standard deviation, which is, again, in order for us to find the score, in order for us to find the score, we have to use this standard deviation, which is the adjusted or the sample standard deviation. And if you recognize that, if you can recognize that over this weekend or when you do your test, you are pretty much set, right? So again, 49% is the percent to the left, which is, this is my 49% or the 49th percentile. And again, looking at this thing here, all I need to do is plug in my calculator, the inverse norm 0.49, the mean, but again, the standard deviation is the sample standard deviation, which is 1.4, which is, again, this thing here, I need to score 181 point or 182 point pint to have to be considered to a 49 percentile. And you probably say, wait a minute, Mr. Tran, 182 is the same as the mean. Again, just because, and the mean, which is 50%, again, because we have to round up, that's why it's the same as the mean. But again, the actual pin is 181.94. Okay. So again, question with this thing here are how to spot out the item to tell you to use the inverse norm versus the normal CDF. Any question with D or E? All right. If you don't have question with D or E, let's take a look at another problem here, which is, again, let's say that this item here, and again, I don't know if Connect Math do this to you guys. I just want to show you guys this problem so that in case if they do this to you guys should know what or why or how to adjust your item. Okay. So again, looking at this thing here, if you read the information, if you read this information, this is what they tell you is, again, a running time for a video submitted to YouTube in a given week is normally distributed with the mean of 390 seconds and the standard deviation of 148 seconds. Now, they say, A, if a single video is randomly selected, what is the probability that the running time of the video exceeds 6 minutes? So the reason why I say that I don't know if they do this to you guys is, if you look at this item here, the information they give you in the problem is in second, but the question itself is in minute. So one thing is, again, they give you this hint that in 6 minutes, the total is 360 seconds. So basically, the idea here is, if they give you a unit, you need to convert to the correct unit before you can do the normal or the inverse norm. Because if you don't put in the correct unit, your item will be wrong, because the mean is 390, but if you put in 6, which is very small, right? But again, 6 minutes is equivalent or equal to 360 seconds. So if your data give you second, your problem, you need to convert to second too. If your data, for instance, if your data is in inch, and then the problem they ask you in foot, well, you have to know that 12 inch is in 1 foot, right? 1 feet, right? 1 foot. But again, you have to convert to the correct correlated unit before you can do any calculation. Okay, so we're not using the 6 minutes here in our problem, but rather we have to use the 360 second. Okay, 360 second. So looking at this thing here, do I need to adjust any of my standard deviation for A? Hopefully you say no, right? Because we are not dealing with any sample, right? They just ask you if a single, based on this thing here, let's say if there's no B, there's no C, there's no D, this is the only problem you see, which is based on this information, they ask you if a single video is randomly selected, what is the probability? Which is, in this case, we know that we're looking for something. Again, what about this word here? What about the exceeds? Do you agree that exceeds is more than 6 minutes, right? Which is, again, looking at this thing here, we are looking for the this is my 360 minutes and exceeds that minute more than, which is I'm looking for the area to the right of this item here, which is I'm looking for area to the right, which is this is what I have. My smaller endpoint is 360. My upper endpoint is some humongous number, which is 10 million. My mean is 390 and my standard deviation is 148. Once you have this thing here, which is again, this thing equal to 58.03, which is again 58.03%. So given this thing here, this is cover, no, the probability of a video run more than 6 minutes is 58%, okay? So what is the difference between A versus B? Well, A versus B, if you see this thing here, they say, what is the probability that the mean running time of the, and hopefully you spot out the difference, which is of the sample, right? So again, of the sample, meaning now I have to do some adjustment because clearly everything is word by word. The only thing different is down here, they have the word sample, right? Which is if they have the word sample, I know I need to adjust this standard deviation, which is my standard deviation is 148 divided by a square root of 40, which is that is the sample size. And once we have that, which is again, I'm still looking for the area to the right of this number, which is 362nd. But now, hopefully you guys say, oh, because we deal with a sample, this is what we have, which is we need to use the sample standard deviation, which is 23.40085469. You can type this as 144 divided by square root 40 if you want. If you use a decimal, make sure you use at least 6 decimal places for me. Don't just use 23.4. This one here might not be that much of the big difference, but there will be some difference, okay? So looking at this thing here, your answer will be 0.9001. So roughly 90%, right? Based on this 40, just this 40 video, 90% of this 40 video, the mean will be exceeds 6 minutes, okay? And similarly, they ask you, would it be unusual for the sample mean were less than, if the sample mean were less than 300 seconds, right? So in order to know if it's unusual or not, we have to find the area under the curve, right? If this area under the curve is less than 0.05, then we say that it's unusual. If it's more than 0.05, we say no, it's not unusual, meaning it's usual, right? So again, looking at this thing here, this is what we have, which is, we know that we're looking for the area to the left, which is, this is 300. And again, if the area to the left of 300, which is this thing, tell me that my lower limit will be negative 10 million. My upper limit will be 300. And again, my mean will be 390. And my standard deviation is the sample standard deviation because they asked us for the sample item, right? So again, that's why I use the 23.40, so on, not the 148. And again, look at this thing here, ladies and gentlemen, please make sure, do not make your eye trick you, because your calculator will give you 6.005 e to the negative 5. So don't just look at that number and say, oh, 6.05005, that is bigger than 0.05, right? This number is not bigger than 0.05 because technically you have to move the decimal 5 places to the left, which is 0.00006005, right? Which is this number is smaller than 0.05, which is this thing here is unusual. It's unusual to have the mean less than 300 seconds, okay? And hopefully you spot out the difference once again. What do they have here? They ask you, first of all, they give you the percentile. So the percentile, you know that you have to find the actual second in terms of this video. And because they ask you for the percentile, or they give you the percentile of the population, what kind of standard deviation am I using? Well, hopefully you guys say that we have to use the 148 and not the 23.4, right? Looking at this thing here, the 87th percentile, which is the 80% on the left, which is now all we need to do is inverse norm 0.87, which is the percent to the left, 390, which is the mean, 148, which is the population standard deviation. So if you remember in chapter 1 or chapter 2, I told you one of your objectives in this class is to determine when are we using population and when we use a sample, and that is what we're doing here, ladies and gentlemen. If we deal with a sample, we have to adjust the standard deviation to become a sample, and if we do in what population, we using the population standard deviation. So question with this problem of A, B, C, and D here. All right, I take that you don't have a question.
Wait, Mr. Tran, real quick.
Yes.
How did so you don't have to add the 0.5 to anything or subtract it?
No. Again, what is the difference between this problem versus the other one? This one here, they ask you to find the probability, right?
Okay.
The other one, when do we add the 0.5 is when they ask you to approximate, which is the next problem you will see.
Okay.
Which is again, that is this question. So now, how do we spot the difference, right? How do we spot the difference between 6.1, 6.2, and 6.4? So if you read this question here, if you read example 4 and the Google it question, right? So according to the net market share, 80% of internet search in a recent year using Google search engine. A sample of 120 search is in a study. So now if you read A, they say approximate. Now you see that last time, the previous problem, the previous 3 problem, they either actually find the proportion of the population, find the probability, find the 80th percentile, or 555, what, right? Now they ask you to approximate. So this is when you have to do a few things. You have to first, if you look at the problem, if you read the problem, do we have the mean? We don't have the mean, right? They only give us percentage and they give us a sample. We don't have the mean. So remember, we need to find the mean and we need to find the standard deviation. And the second thing is because they ask us to approximate, that is when we need to adjust the endpoint. And how do we adjust the endpoint, or how do we do the correction of the endpoint? We have to either add 0.5 or subtract 0.5. Okay, so looking at this thing here, before we can do A, we need this thing here, which is we need a mean. Reminder, the mean is the n times the p. And we need the standard deviation, which is reminder, the standard deviation is the n times the p times 1 minus p, and then we take a square root of that result, or a square root of n times p times 1 minus p, which is if I plug it in, this is what I have. And like I said, you can either put in a square root of 16.932, or you have to put in 4.114851, at least 6 or 7 decimal place. I use the whole thing, it's just a few number crunching in, so I use the whole thing. So looking at this thing here, so given this item, now let's take a look at A. They ask you to approximate, which is again, if you spot the different, that is the different, right? They tell you to approximate, which is now the idea of approximation is we have to kind of estimate, which is we have to adjust the item. So approximate the probability that more than or equal to 94 people using Google, right? So looking at this thing here, do you agree that more than or equal to, meaning X is greater than or equal to 694, right? Great, more than, which is bigger than, or equal to, which is we have an equal sign. So given this thing here, if you remember yesterday and the day before, this is what we do, right? We know that it's more than 94. More than 94, then all I need to do is let me sketch this item here. My 94 is here. And again, what side is more than 94, which is the side on the right? More than, greater than, bigger, above, those number, those words is tell you to find the area to the right of 94. right? Looking at this thing here, before we can do this, unlike the previous one, we put in normal CDF 94, comma, 10 million, comma, the mean, comma, the standard deviation. Because we estimate them, we have to ask ourselves, we have to adjust the endpoint, which is